you took chemistry before in Gen Chem, you heard of acid-base neutralization reactions. You had an acid plus a base. You would end up with salt and water. We had, for example, hydrochloric acid plus sodium hydroxide would give you sodium chloride and water. Now, a salt is any ionic compound that has a cation and an anion, doesn't have any hydroxide ion in it. So we can do acid-base neutralization reactions with carboxylic acids and any base. So this is what we're going to do. An acid plus a base will give you a salt and water. So let's say I had this acid over here. Can everyone see that this is propanoic acid? Propanoic acid. And if I wanted the common name would be propionic acid. Okay. The base that we're going to use, let's say it's sodium hydroxide, a nice strong base. All right. So what's going to happen? This proton from here, remember it always leaves its electron behind. The proton, this hydrogen ion, is going to hook up with this hydroxide ion. And HOH, what does it become? It becomes water. So that's our water. So what's left over is a sodium ion and a propanoate ion or a propionate ion. So this becomes the carboxylate ion. Now make sure you can see here because I noticed that in a few of the videos I'm not angling it properly, so you can't really see what I'm doing, which is unfortunate, but hopefully you can figure stuff out. So this is what's left over after this hydrogen ion went away to hook up with the hydroxide. You have this negative charge, and then you have the sodium ion. So you have this cation and this anion, you've just created a salt. What is the name? And then the other product, obviously, is water because it's HOH. What is the name of this salt? This is sodium propanoate or sodium propionate. So let me angle it a little better, write it down. So for the IUPAC name of this salt, it would be sodium propanoate. Remember what we talked about in the video before? We talked about the name of the carboxylate ion. You get rid of the ic acid and you just put in the 8. So instead of it being propanoic acid, you get rid of the ic acid, it becomes propanoate. That's IUPAC. For common, this is sodium propionate. Okay? So this is how you make salts. This is how you name salts. All you need is any carboxylic acid, any base, you end up with a salt and water. One thing you should know is that salts are more soluble in water than carboxylic acids. Why do you think that is the case? Well, it has to do with these charges. It's a lot more polar. So salts become so much more polar because they have all these charges, so much more soluble in a polar substance like water than just the original carboxylic acid. Yes, granted, it can hydrogen bond, but still, the charges make it more polar, more soluble. And that's why a lot of drug companies turn carboxylic acids into salts to turn them into water-soluble drugs. All right, so that is the acid-base reaction to form salts. Now we're ready to move on to esters. Let me first show you how you synthesize an ester, and then we'll talk about naming esters. By the way, esters have a beautiful smell. The smell of raspberry is an ester. The smell of pineapple, that's an ester. Perfumes, a lot of the floral smells, those are all ester molecules. What is an ester molecule? Remember how we said that an ester looks like this, an R, carbonyl, O, R. This, when you recognize carbonyl O, that is the ester functional group. Or how do you synthesize? How do you make an ester? You have to start off with a carboxylic acid, any carboxylic acid, and any alcohol. Okay, so for the heck of it, let's name this. This would be ethanoic acid, and this is methanol. That's the IUPAC name. What would the common names be? This would be acetic acid, and this is methyl alcohol. Okay, remember from the alcohol chapter. All right, so we've got the name of the original carboxylic acid, the name of the original alcohol. Let's put them together, heat them up, add a catalyst, usually an acid catalyst will do, and heat. Let's do this for heat. And let's see what we get. Okay, I'm going to draw the ester up here. Okay, so the results are going to come over here. Let's see what happens. Now, this is what you guys have to do. Take the OH from the carboxylic acid and the H from the alcohol. All right. So what did we just create? We created a molecule of water. So one of the products, this, by the way, this whole thing is called esterification. Esterification just means the synthesis of an ester. Okay, so we've got a carboxylic acid. You have to start off with a carboxylic acid and an alcohol. You take the OH from the carboxylic acid, you take the H from the alcohol, you have a molecule of water, and then you put all this together. So we've got this, and then what's left over here is something like this. So we combine them. So carbonyl O, you've got the ester. You've just created your first ester. Now let's learn how to name the ester. Do you guys remember how to name carboxylate ions? Remember, this would have been an ethanoate or an acetate. So we're going to use the same type of terminology that we did for the carboxylate ions to name the second name of the ester. The first name of the ester is going to be this alkyl group. You tell me what alkyl group you have. Is it a methyl? Is it an ethyl? So you look at the ester and you look over here and you say, all right, what alkyl group is attached to this O that is part of the ester functional group? Well, this is a methyl. So this would be called methyl ethanoate. That is the IUPAC name of that ester. Methyl ethanoate. Remember what I said? You use the same terminology that you use with the carboxylate ions. So the carboxylate ion of an ethanoic acid is ethanoate. Carboxylate ion of an acetic acid is acetate. So if you wanted to know the common name of this ester, okay, I'm going to erase this. You guys have it already. If you want to know the common name of this ester, this would be methyl acetate. Why acetate? Because the common name of the original carboxylic acid was acetic acid. Why ethanoate? The IUPAC name of the original carboxylic acid was ethanoic acid. All right, let's do another one. Okay, again, there's plenty of practice in the homework, plenty of practice in your book, but let's try another one. I'm just going to flip it over so that you're used to seeing it anyway I give it to you. So let's say I have this molecule over here. See if you can recognize what this is. All right, let's see if we can recognize what these are. Let's give them their IUPAC name and their common name. So what is the name of this thing over here? This is 3 carbons, OH in the middle. So 2-propanol, or what is the common name? Isopropyl alcohol. So this would be 2-propanol. That's IUPAC. And common is isopropyl alcohol. Okay. You recognize that this is a carboxylic acid. 4 carbons. IUPAC is butanoic acid. Common, butyric acid. Okay, so you're going to have to flip-flop between common and IUPAC and know how to do this. All right, so what did we say we're going to do? We're going to remove the OH from the carboxylic acid, the H from the alcohol. They form water. Now let's stick it all together. So I've got this. So I still have this isopropyl group. I still have these 3 carbons, and it's hooked right in this middle. So it's still an isopropyl. Remember how we name esters. We name this like a carboxylate ion, and that's the second word. And then we name this as an alkyl group, and that's the first word. So this is isopropyl butanoate. They're 2 separate words. Isopropyl butanoate. And if you wanted to do the common name, put it here so you can see, it would be isopropyl butyrate. So they're very similar, but remember, this is butanoic acid, this is butyric acid. Common, IUPAC. IUPAC, common. So the top one is the IUPAC, the bottom one is the common. The more you practice, the better you will be at naming esters. Okay.